Hey, Astronomy 152. I was here today and I wanted to talk to you guys about the different types of stellar evolution. Okay, and so here we go. We're going to talk about the way that different stars change over their lifetime. And really, the main point would be we have two types. We have a high mass and a low mass. Okay, now they're both going to start off on the variable type, and this part they're very, very young. That means that the star is going to swell and contract and swell and contract, and the reason they're called the variable type is because their light varies over the course of about 2 weeks. They'll get brighter and then they'll dim off. All right. Now, how they vary depends on what kind they are. If they're a Cepheid variable or a Lyra variable, they have what's known as the period luminosity relationship. You might want to look into that. At any rate, these these young stars, variable stars, all right, a Cepheid variable is going to come back, and we'll talk more about that when we get to galaxies. Now, the next part, and here I want to stop for just a second and say that a young star is going to be swelling in and out a lot, and so it's going to have really vicious solar winds, and so maybe that's how Earth lost its primordial atmosphere, was by these vicious solar winds once the sun lit up. Anyway, the bombardment era was worse than we thought, huh? At any rate, the next part I want to talk about is main sequence. All right. Main sequence would be when you have hydrogen turning into helium in the core of the sun, okay, or a star like the sun. In a star that's bigger than the sun, you'd still have hydrogen turning into helium, but you'd also have another process known as a CNO process. That's where carbon, nitrogen, and oxygen are fusing as well. This leads to a giant star. This one is called a blue giant, and usually I think they're an OB or A class star, whereas a low mass star would be a F, G, K, or M class star in general, at least as long as they're on main sequence. All right, main sequence means that they're kind of mid-aged, and they're just going to be burning hydrogen in their core for the most part. Okay, although higher mass ones might have something besides hydrogen going on in their core, huh? Now, what happens in both phases is you're going to go through a giant phase. We've now entered into what a lot of people call the old age phase of the star. Okay, at any rate, here you're going to have shell burning going on in the two different kinds of stars. Okay, you have shell burning going on, and that causes the stars to swell up. Okay, in the case of a low mass star, you're going to have a red giant, but in the case of a high mass star, you'll have a red supergiant. Okay, now that's important because now, for the first time, hydrogen is turning into helium, and that's what I'm calling hydrogen burning. But of course it's not burning, but that process is happening outside of the core of the star. Okay, not that easy, huh? Okay, the next part we wanted to talk about was the stellar explosion part. Here you're going to have a high mass explosion or a low mass explosion. High mass explosions are always going to be talked about as supernova. We'll have a different video where we discuss the different types of stellar explosions. A low mass star is always going to be referred to as a nova's explosion. The thing that's left over after the explosion in the case of a low mass star is called a planetary nebula, and in the high mass star is called a supernova remnant. Now here, I want you to look up these two objects so that you're familiar with them. When I call them by name, they should bring an image to your mind. But a supernova remnant is the Crab Nebula. It's probably the most famous one. It happened in 1054. Your book has a lot on that one in particular. But also, for a low mass star, a typical stellar explosion try to get through this. Stellar explosions. The low mass one is caused by helium flash, and the high mass one is caused by the core collapse. All right, look up crab. Okay, super quick, because I don't know how long it's going to last. But anyway, the remnants, the last three remnants for a high mass, you can have a pulsar, which is a type of neutron star, a black hole, and a white dwarf. A white dwarf is still made out of matter. A pulsar is barely made out of matter because it's only neutrons, but a black hole is not even made out of matter anymore, and those are what's left over of the star after it's all said and done. Okay, at any rate, hopefully this will give you an idea on what to do for your stellar evolution presentations. Anyway, you need to do two. One will be on something besides a black hole, and then one will be on a black hole. All right, good luck.